So we're doing 2 lessons today. The book is back to rounding again. This is probably like the 3rd time at least that we've done some rounding. So that would mean one of 2 things about rounding. If the book's doing this now for the 3rd time, what do you think that means in their opinion about rounding? Probably that it's important. The other thing it might mean is that it's hard, but I think we would discard that because I don't think any of you probably think rounding is really all that hard, but it is pretty important. It's a skill you should step away from 7th grade being able to do. So I'm not going to spend a whole day rounding, but I will do a little quick rounding review. The book thinks it's important. I agree with them. So quick rounding review, but the main lesson is going to be this other call. But if we want to round this to the tens place, can somebody talk through out loud the process of just how you'd go about rounding? Yeah, go ahead. Okay, so first we go to the tens place, which is the 6. So 6 is where we're going to have to maybe make some changes or maybe leave it alone. We always look to the right. So 7 is the boss of this question. 7's going to boss 6 around and tell 6 what to do. Yep. Anytime, what's the rule on that? What does this number have to do to change? 5 or above. Sometimes people say 5 or above, give it a shove, or however they say that. So if this is 5 or more, this is going to go up to a 7. And then how do you fill in all these other places?
You just write everything to the left you keep.
Yeah, we just keep everybody to the left,
Then 7 goes to 0.
and then we just do a 0 on the right. So if we go to the hundredths place, somebody else jump in. If we're looking at the hundredths place, who are we looking at? You can just yell, it's fine. 5. The boss is going to be 6. 6 tells 5 to go up to 6. Over to the right, 2 zeros, and everything to the left.
1, 2, 3,
Just copy 1, 2, 3, 4. 1,000. Now who are you looking at for 1,000? 4. Who's the boss of the 4? The 5. We always look right 1. So if we're looking at 4, 5's the boss. What's 5 telling 4 to do? Go up 1 to 5. To the right, 3 zeros. To the left, same stuff. One more time. 10,000. Now where are we looking for 10,000? 3. The boss would be the 4. What's 4 telling 3 to do? Stay the same. To the right,
0,
bunch of zeros. To the left,
1, 2.
just 1, 2. So that's rounding. The only thing that gets a little weird, what can get a little weird with this? Anybody remember? I don't even know that I'd say harder. I could make this a little harder. Decimal places maybe, but I was thinking of something else that kind of creates a big reaction.
Zeros?
Yeah.
Oh, yes.
Yeah. If I do something like that, if I want to round this to the 10, that's where we're rounding. This is the boss. That tells this to become a 0, but we have to carry the 1 to make 0 and carry a 1. 0, carry a 1, 0, carry a 1, 0, carry a 1, get a 2. Broken chalk. And we'd end up with something like that. Sometimes if there's a lot of 9s, you get like this chain reaction down the question to just get all of these answers would end up being 2 million. Question about that little weird possible once in a while. You can do a small turn, we'll take a move over to this. This looks like something we did recently, but it isn't. Does anybody have an ability to do any of these questions without me telling you how to do them first? We'll talk it out for sure, but anybody have an idea of how to start or a thought of what an answer might be?
The first one is 75%.
It is 75%. I agree with that. can anybody figure out how it's 75%?
Because 6 is 2 and 8, so we would, never mind.
Okay.
Oh, it's all fourths, 3/4.
It is 3/4. Yeah, before you thought about 3/4, what did you probably think about?
Percentages.
Nah. How do you, anybody, how do you probably make the jump to 3/4 from where?
Reduce,
Reduced from where?
just like, reduce just 8.
6/8. You probably thought 6/8 first, probably reduced to 3/4. Then where'd you go from there?
I want to check percent, but you can make this
You could go to decimal, that's 0.75, and then make the hop. That's fine. Here's what sometimes people get this confused with. We had a set maybe like a week ago, within the last week. It looked a lot like this, but it isn't this. What did we do in the set that looked like this about a week ago? Does this remind anybody of something we did? It just made the quiz. We had like a 2-step plan the other day. In your book, let's look at, go to set NN. These look a little bit like what's going on in NN, but it isn't what that is. Anybody observation? What does this have in common with what's going on set NN?
Of.
The word of. Okay, when we did set NN, the of meant we had to
Multiple.
multiply. On this, the word of did not mean that we were multiplying. We did not multiply 8 and 6. We did not get 48. Can anybody spot for us why on NN we were multiplying, but this we were more dividing? They both used of though.
Because of was between them, so it's kind of like pointing, saying that like,
Yeah, the of was between who?
two numbers.
That's perfectly, absolutely what I'm searching for. On set NN, the of is connecting two numbers. So the of, you want to multiply the two numbers together because of connected numbers. So if you, in your mind, replace of with times, we were just multiplying those numbers on NN. Today, the of does not serve as a bridge between two numbers. What's going on here is, if we think of the of as multiplying, 8 is multiplying a mystery number. We don't know what that is. Okay. So this is more like the equations with the variables. Like sometimes we've had, 8 multiplying a box to equal 24. And then we ended up with 8 next to a letter to equal 24. When you have those mystery numbers, those variables, those boxes, we always do the opposites. Okay, so on NN, the multiply was joining known numbers, just multiply. But on this, when the of is joining a number to a mystery number, we're doing the opposite. We're going to look to divide. So what I'd suggest on this group is write yourself a fraction to get yourself organized, and then see where that takes you. Okay, so what percent of 8 is 6? We thought about 6 over 8. And then you can do a lot of things. Okay, we've turned fractions into percents a lot of times. So one way you could do this is work through a decimal. And how does a decimal become a percentage?
When you move it
Through the
over.
decimal right twice. Another way you could do is like your box to top, you guys like to say. The bottom number goes out, top number goes in. Percentages are always out of 100, so we turn that into 600 instead of 6. We could divide that to get 75. There's other ways you could do it. But in any case, you'll have to work your way from fraction into percentage. However you're best doing that, you've got to make that choice. The only danger is doing the fraction upside down. Okay, so this, our first main choice is, are we putting 5 on top of 6, or are we putting 6 on top of 5? We are putting 6 on top of 5. How do you know which goes on which? Because there were probably people that would say, put 5 on top of 6 because it's smaller, and that isn't it. Why is 6 on top of 5?
Because 5's like in all.
It is. What gives that away? There's something about the sentences that gives away where a number goes each time. There's a giveaway why this one had 6 on top of 8. There's a giveaway why this has 6 on top of 5. Anybody feel the giveaway?
What percent of 5 is 6? So it's asking what percent of 5?
Yeah, so the of tells you the number that's on the
Um,
bottom. Think about all your experiences taking tests in your life. You say to your teacher, what is this out of? Your teacher says 12. That means on your paper, your teacher could have written whatever over 12. Or the teacher says, this is out of 30. You're expecting to see on your paper a number on top of 30. Whatever it's out of, the of tells you the bottom number. So if it's of 8, 8 to the bottom. It's of, this was of 5, 5's to the bottom. Let's do the fractions first on all of these and then we'll clean them up. So is this 3 on 10 or 10 on 3? 3 on 10. Why 3 on 10?
It's saying like, are you asking me or?
Anybody?
Because like,
It's the key to know who goes where.
of
Of puts the number on the
bottom.
bottom. So of 10, 10's on the bottom. Next one, 4 over 11, 11 over 4.
4 over 11.
4 over 11, because the of 11 puts the 11 on the bottom. Last one of those,
13 over 20.
13 over 20. The of 20 does a 20 on the bottom, 13 on the top. So again, create a fraction, whatever the of number is, put it on the bottom, other number on the top. This sometimes freaks people out. This is fine. If this were your quiz, how did this happen? Bonus point or something? So 6 over 5 is fine. Let's turn all of these into percentages. I don't care which one we do first. Anybody? Take on a fraction, turn it into a percentage.
6 over 5 can become 116.6 with 1 over 6%.
Disagree. It is over 100, but it isn't that.
3 over 10 is 30%.
It is. 3 over 10 is 30%. I agree. How did you do that? There's a lot of ways. How did you do it?
I just put the fraction to the decimal. I made the fraction to a decimal.
Okay, yeah, that's fine. We can make the fraction into a decimal, 0.3, and then bounce that twice, and get a 30. I like it. Another way we could do this is name change machine it. We haven't talked about that today. Percentages, we like them to be out of 100. So if I'm going to make this switch, I multiplied by 10, so multiply the top by 10. That's another way we could get 30%. We could have also divided. If you like to divide, dividing, we could have done 10 out, made 300 in, it all would lead to 30%. That's all good. Anybody got another one?
6 is 110%.
No, it is over 100 though. We're close on that.
4 11 is 36%.
That's close. Did you go through the decimals? Did you divide it or?
I just used knowledge from
Okay,
the chart.
this is close to 36. Yeah, chart can get us in the neighborhood of 36. This is over 100. We're getting
The
there.
last one is 65%.
Yeah, how can you get 65% off of that one?
I use a name change machine.
Name changer machine is probably the best way to do that one. If you turn the bottom into 100, you multiply by 5. So top times 5 is 65. So I like that name changer machine trick. I do that one a lot.
But the top one's 120.
Yeah, this is 120.
That's what I was gonna do. I just didn't understand.
So how did you get to 120 that time?
I
Oh, that's what it
changed it to 1 and 1/5.
Okay, we could go to mixed, 1 and 1/5. Then what did you do with that?
I did made it, the 1 and 1/5 of 20%.
Okay, yeah, you could do 1/5 is 20, and then the whole number always gives you 100, so that's fine. We could have gone decimal. 1/5 is 0.2. Bounce it twice. That's another road to 120. We could have gone name changer machine. If I go from 5 to 200, or excuse me, 5 to 100, I multiply by
20.
20, so do top times 20. That's another way to get the 20 part of it. We could have also done 5 into 600. That would have given 120. I don't know what ways you yourself are most comfortable doing percentages, and it doesn't matter. Just find a way, whatever way you like the best. Work through name changers, work through decimals, work through division, it's all good.
411 is just 36 with a line on it, please.
That's getting closer. Yeah, the bar is the issue. I like that 36. The 4/11ths, if we use our chart, is a .36 that has a bar on it. And then if we bounce this, there's still a 36, there's still a bar involved. It's just a question of how to write it.
36.36%. Oh, with the line on it, the 36.
Which 36? That's the one.
last
The
one.
last one. I agree. That would be perfect on that one. If we take this decimal on the chart, .36 with a bar, and we bounce the decimal twice, remember this means 36, 36, 36, 36. There's no end to that pattern. So if we bounce twice, we get that 36, which was good. You gave us that 36 way back. There just needs to be a decimal, and then that bar stuff still needs to just be around. So that would be a perfect answer for that one. This could also be 36 and 4/11%. If you wanted to divide 11 into 400, if you divide 11 into 400, you might get a fraction thing instead of a decimal thing, and that's fine too. It's good and bad. Sometimes people get grouchy when you have like 10 ways to do a problem. Sometimes it makes people happy because you got a lot of options. I don't know how it makes you feel, but it doesn't matter. Deal with it. We have to get somehow from fraction to percent. However you get there is kind of your own style choice to make. Any question? You good? So I think that's it. So homework's going to have a tiny bit of rounding. So we're going to go to 289. 289, there's an ABC. The only thing you're doing on 289 ABC is round, round, round. There's just 3 little rounding questions there to remind you that that exists. The main thing is on the back, we're up to set PP. So set PP is like this. You create a fraction, the number with of goes on the bottom, but you have to just turn that into a percentage. A couple people had a little bit of a smirk on set PP. Sometimes 7th graders can't handle if their teacher said PP. I know it happens once a year. Set P, some of those people get giggly. Set PP makes people even more giggly, but this is where we are. So 289, we're doing the letters ABC. Set PP in the back, off we go. There's maybe 10 minutes left. See what you can do. If you happen to get done, I can hold it for you if you want me to. You can stop the video there.